Hello, we are discussing about GATE 2015 ECE paper, and this question is related to digital circuits. Look at the circuit diagram of a counter that consisting of JK flip-flops, and each JK flip-flop is also having an active low asynchronous input that is given as RD bar input. So we are going to calculate what is the modulus of this counter and whether it is acting as up counter or down counter. So first we need to identify whether this counter is synchronous or asynchronous. For that one, the basic difference is for synchronous counter, clock is given to all flip-flops simultaneously. That is, master clock or system clock is going to be directly given to all flip-flop clock. That is, all flip-flops are clocked simultaneously with a master clock. Whereas in case of asynchronous input, generally the main clock or system clock is going to be given to LSB flip-flop. Output of LSB is going to be given as clock for the next flip-flop. Okay, so clock of all other flip-flops except LSB are going to be connected from the output of previous stage. So that is what you can observe over here. Actual clock is given to this flip-flop, that is Q0. So Q0 is treated as LSB flip-flop, and output of Q0 is acting as clock for the Q1. Okay, and output of Q1 is acting as clock for the Q2. And this is JK flip-flop. Okay, operation of JK flip-flop, we know that one, whenever J is equal to 1, K is equal to 1. When J is equal to 1 and K is equal to 1, by that time if clock edge occurs, okay, if negative edge clock occurs, that is, if you apply a negative edge clock, then next state will be complement of present state. Otherwise, next state is same as present state. Okay, J and K inputs are going to be synchronous inputs. They don't affect directly the output. They will always have effect on output along with clock edge. If clock edge occurs, then only the values of J and K will affect the outputs. So J and K are going to be treated as synchronous inputs. Their operation is in synchronous with clock edge. And whereas RD, that is reset actually, that reset input is going to be called as asynchronous input. It is not in synchronous with clock edge, so it directly affects the output whenever there is a change occurs. So if RD is equal to 0, since it is active low input, if RD is given with 0 at that time, that will reset the output of that flip-flop. If you give RD bar common for all flip-flops, at that time 0 for RD bar is going to be making all flip-flops to reset. Okay. Now we need to calculate whether it is up counter or down counter, and whether it is modulo 5 or modulo 6 counter. Okay, so this is LSB and it is MSB. Now this is a NAND gate, and output of NAND gate is going to be connected to reset pins of all flip-flops. Assume that one reset pin is activated, that is, output of NAND gate is 0. Okay, so the flip-flops has been resetted. By that time this will become Q2, Q1 and Q0. It will become all zeros. Okay, whenever they are all zeros, at that time this NAND gate input will become Q2 and the other input is going to be Q1. If they are 0, 0, at that time one of the input for the NAND gate is 0, at that time output is always 1. So that will give output as 1. And this 1 is nothing but active high signal. It doesn't affect the output since this reset pin is active low. So now it performs normal operation. Normal operation is nothing but you are applying a clock edge, and based on the clock edge, if negative edge is going to be present at input of any flip-flop, output gets toggle. Otherwise output maintain the same state. So now assume that one you are applying a clock edge. Okay, if you apply clock edge, if you apply one clock pulse is nothing but every clock pulse is going to be, clock pulse is a complete duration cycle. So in that one you will get a negative edge also. So this negative edge is given to LSB flip-flop. So LSB will toggle its value 0 to 1. And next 0 to 1 is going to be observed as positive edge, and positive edge you are giving it to Q1, but Q1 is sensitive to negative edge. So Q1 doesn't respond for that positive edge. So Q1 maintains 0. And Q2, for Q2 output of Q1 is not changing, so that there is no edge. Whenever there is no edge, at that time Q2 also maintains same value. So previously it was 0, now it is going with 1. And if you are going in this way, you will get 0 1 0 0 1 1 similarly. So it is acting as up counter. First one thing what we have considered is this circuit diagram is acting as up counter, and we are now interested in calculating the modulus. So again it has to come back to reset state. To come back to reset state, what a NAND gate requires is nothing but outputs of, that is output of NAND gate is 0 when all of its inputs are at logic 1. Okay, we know for a NAND gate, the property of NAND gate is if all the inputs are going to be at logic 1, output will be 0, or if at least one input is 0, at that time output will be goes to logic 1. So to get logic 0 at the output of NAND gate, so that you can get the reset of all flip-flops, to get that condition, it makes Q2 is equal to 1, Q0 is equal to 0, Q0 is equal to 1. This is not Q1, it is Q0. So output of NAND gate is equal to 1 if Q2 is equal to Q0 is equal to 1. So for that one, this is going to be a state. So whenever Q2 is equal to 1, Q0 is equal to 1, at that time reset will become 0. That makes resetting of all flip-flops. So since it is up counter, Q1 will come first 0, later it will become 1. Okay, so whenever Q2 is equal to 1, Q0 is equal to 1, by that time Q1 can be anything, but you must consider 0 since it is acting as up counter. Up counter is nothing but the value is going, modulus are going to be increasing. So if you are going with Q1 as 1, at that time modulus will become 7. If you go with 0, modulus is 5. So this will be considered as 0 for Q1. Since it is up counter, it is 1. If it is acting as down counter, you must consider 1. Okay, so 101 is going to be treated as this state never occurs. Okay, 101, it never occurs because this state is not going to be visible in the outputs. It is present only for minute duration, because the output, whenever the outputs are going to be try to become 101, by the time output of NAND gate, since it is combinational circuit, it directly reflects the output will become 0. That 0 is going to be making the resetting of all flip-flops. It doesn't wait for the clock edge. So the actual states are going to be 000, 001, 010, 011 and 100. 101 is not going to be a part of sequence. So total is going to be treated as 5 states. Total 5 states, and it is acting as up counter. So this will be treated as modulus of 5, mod 5 or modulus of 5, that is 5 unique states, and mod 5 up counter. So the answer is A. Answer is A, mod 5 binary up counter the circuit works as. Thank you.